Welcome back once again. Today we're going to still work with angles. Two other types of angles that we're going to talk about are vertical angles and adjacent angles. So again, you should have notes quadruple zero here to fill out the definition and examples of these couple of words. So vertical angles are angles that are opposite each other when two lines cross. They share the same vertex, and the measure of vertical angles are congruent. Now, congruent is another vocabulary word, and we'll get there in just a second, but take a look at this diagram. Angle 1 is vertical with angle 3. They share this vertex point, and they are opposite from each other. Angles 2 and 4 are also vertical because they also share this vertex point, and they're opposite from each other. The markings also tell you that those angle measures are congruent. And what congruent means is equal in value or to have the same measure. This is the symbol that reads congruent. So if you see that symbol, the equal sign with the squiggly line on top, that means congruent or equal in measure. The other type of angles we're going to talk about today are adjacent angles. Adjacent angles have a common vertex and a common side. The angles may or may not be congruent depending on the figure given. So in the diagram on the right, angle DAJ, this angle here, and angle JAB, this angle here, are adjacent because they share this vertex and this side AJ. Pause the video and write down the definition and examples of these three words: vertical angles, congruent, and adjacent angles. Back to notes 24. We're still on notes 24. And this first page here just goes through what we just went through as far as the vocabulary is concerned. But I want to talk a little bit more about adjacent angles. They have a common vertex and a common side, but classifying angles as adjacent really just tells us that they're next to each other. Being adjacent doesn't give us any real useful mathematical information if we need to find the measures of any angles. So it's just a classification. Let's take a look at some examples. Example 1, name two pairs of vertical angles and two pairs of supplementary angles. Now there's lots of correct answers here, but let's just talk about a couple. So let's start with vertical angles in this first figure. So remember, vertical angles share, let me pick a different color, a vertex point. So what angle would be congruent or vertical with angle ACE? Did you say angle BCD? Those are vertical. Are there any other pairs of vertical angles? There are. Angle ACB is a vertical angle with angle ECD. Notice that that vertex point, C, is always in the center. Let's talk about some supplementary angles here that we see. Supplementary was from our prior lesson. Supplementary. So remember, with supplementary angles, we're looking for angles that form a half circle, semicircle, and follow along a straight angle. So if I look at this straight angle here, what angles do we see that are supplementary? Well, angle ACB is supplementary with angle what? You see that semicircle? Good. Angle BCD. Or it could go this way and also be supplementary with ACE. Let's pick another pair. Let's say we are talking about this straight angle here. What would the straight angle, or what would the supplementary angle be to angle ECD? There's two good answers here. Either BCD over here or ACE. So ECD and ECA or ACE. Let's try again. Let's start with vertical. Let's pick an angle. Angle IGJ. Angle IGJ. What angle is vertical with angle IGJ? Remember, they share a vertex and they're opposite from each other. Did you pick out angle LGM? Good job. Let's try another. What angle is vertical with angle JGK? So let's talk about JGK. Where's the vertical angle? Good. Let's try one more. I know it says two, but let's try one more. What about angle KGM? What's a vertical angle with angle KGM? So KGM is here. Did you say angle JGH? You'd be right. Now let's talk about some supplementary angles here. What is a supplementary angle with angle JGH? Good. Let's try one more. What's a supplementary angle with angle, let's see, LGM? Remember, it has to form that half circle and fall along a straight angle. So this is angle MGI. Good. Okay, let's move on. So now we're going to tell whether the angles are complementary, supplementary, or vertical. We'll write and solve an equation to find the value of x and the value of each angle. So on A here, we see that this angle here and this angle here share a vertex. So what type of angles are they? They're vertical. And what do we know about vertical angles? They're congruent, which means they are equal to each other. So when we write our equation, we're going to set those two angles equal to each other. Now, when we solve for x, x equals 45. And so if we substitute to find out this measure, 2 times 45 is 90, plus 6 is 96, which is what this angle was. And that's good news because vertical angles should have the same measure. Now let's take a look at number 3. So these two angles share what? A vertex and a side. So these are adjacent, next to each other. But we know that that doesn't give us any mathematical information. So these angles are also another classification, complementary, like we learned in the last lesson. That gives us information. So then we'll write our equation from here and solve. Is this degrees? It is, because this is just x, so this would be 49 degrees. Okay, let's take a look at example 4. So these two angles I see, okay, they share this vertex here, and they also share this side. So they can also be categorized as adjacent. But again, adjacent doesn't tell us much. What do you notice about these two angles? What shape did they form? And what kind of side do they fall along? This half circle along a straight angle, right? So what type are these? Supplementary. Very good. Write and solve an equation to find the value of x here. Number 5. Let's take a look here. So we have this angle here and this angle here that we're talking about. Well, I see that they're opposite from each other and they share this vertex. So what type of angles are they? They're vertical, right? They're not adjacent because they don't share a side. But we know that vertical angles are congruent. And congruent just means that they are equal. So we're going to set their values equal to each other. Now here you'll see variables on both sides, which we haven't worked on yet for some of you. Others of you we have. So if you haven't, work with me here. Pretend that this 2x wasn't here. What would you do? You would subtract 42. So if we subtract 42 from both sides, we have x. Our 2x is really there, so it will come down. And 1 minus 42 is negative 41. So we also need to move this 2x to the other side to collect variable terms on the correct side. So in order to do that, we're just going to subtract the entire term. And x minus 2x is negative 1x. We'll divide by negative 1. And so x equals 41. Is that degrees? It's not this time because we don't have any angles that are just x. So we're going to have to come in here and substitute for x. So 41 plus 42 is 83 degrees. And then we'll check over here. 2 times 41 plus 1. What's 2 times 41? 82. And 82 plus 1? 83. Which is great news again, because vertical angles are congruent. Take a look at number 6. What classification would you give number 6? Does it have more than one classification? See if you can write and solve an equation to find the value of x here. Good job. And here's our last problem. A tree is leaning towards the ground. How many degrees does the tree have to fall before hitting the ground? Well, again, the tree is parallel or sticking up from the ground, and the ground is our straight angle. And we see that these two angles form that semicircle against the straight angle. So what type of angles do we have? They're supplementary. And since they also share this vertex and this side, they're also adjacent. But again, adjacent doesn't tell us much info. So we need to find the value of x. And then you have to determine how many degrees the tree has to fall before hitting the ground. Which angle is that? Great job. See you next time.